Section 4.5, Writing a function rule. Learning target. I will be able to write equations that represent functions. Warm-up. You and a friend are swimming 20 laps at the local pool. 1 lap is the distance across the pool and back. You both swim at the same rate. Your friend started first. The trail of arrows shows how far he has already swum. What equation gives the distance you have swum as a function of the number of laps your friend has swum? How far have you swum when your friend finishes? Explain your reasoning. So to answer the first question, let's let x equal the distance your friend has swum. I kind of like the word swum. I don't use it a lot. Kind of liking it. So if x is the distance your friend has swum, and you start swimming after your friend is 15 meters ahead, you will always be 15 meters behind your friend, and that is going to be indicated by y equals x minus 15 as the equation. Now the other thing we note is that 1 lap is back and forth. It's 25 meters one way. 2 times 25 is 50. So 1 lap is 50 meters. So when your friend has finished, they've swum 50 meters. So if we substitute the 50 in for x, you get 50 minus 15, which is 35 meters that you've swum. Example 1, writing a function rule. According to an article in Pediatrics, for every hour spent watching TV, high school age children spend 18%, which is roughly by my calculator 2.16 hours for 12 hours, less time doing homework per week. If a student does at most 12 hours of studying per week, what equation gives the amount of time a student spends doing homework in response that is depending on the number of hours spent watching TV per week? Let's let x equal the number of hours spent watching TV per week and y the number of hours spent studying per week. So if we study for at most 12 hours, then for every hour of TV watching, we're going to lose approximately 2.16 hours of studying. We have the following equation. So y, the number of hours that we spend studying every week, will be 12 hours minus 2.16 times x, the number of hours spent watching TV. So for instance, if you were to watch, let's say 5 hours of TV in a week, let's see how many hours of studying you would have according to this formula. That would give us 12 minus 2.16 times 5, which is 1.2 hours of studying in a week if you were to watch 5 hours. Now I got this from an article from the magazine Pediatrics. I suspect there are limitations, but by and large you get the idea. Example 2 is about revenue. I just want to point out something, that revenue is part of the equation for profit, and we'll be dealing with revenue here, but profit, which is the amount of money you actually make, equals revenue minus cost. Example 2, writing and evaluating a function rule. Concert revenue. A concert seating plan is shown below. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum possible total revenue? So revenue is just the amount of money you bring in. It does not include the cost of hiring people for security, for stage work, for the venue itself, the rental or cost, all of the other costs not included. And that's why profit is a different thing. The very thing that gives you the greatest revenue sometimes will not give you the greatest profit because you'll get more cost. Generally, though, I think with concerts, probably the greater the revenue, the greater the profit. All right, so we have a couple of different pieces here. We are told that the reserve seating is sold out. We have 10 by 12 seats, so 10 rows of 12 seats. So that's 120 seats in the reserved seating. But the reserved seating is sold out, so that is already a revenue that you can count on. That isn't going to vary. That's a fixed revenue. So our revenue from that amount, so again, that's $25 times 120 seats, so that's $3,000 that you have coming in from the reserved seating. The general seating, on the other hand, is not sold out. You have potentially 30 rows of 16 seats per row at $10 per seat, but you don't actually know how many people, so we'll set up an amount for that. So general seating revenue, which I've abbreviated as GS Rev, equals $10 times the number of seats. Now, if we let X equal the number of seats in the general seating area, that's $10 times X for the general seating revenue. But what we have to recognize is there's actually a limitation or a constraint on the number of seats for general seating. Because we have 3 rows times 16 seats, 30 rows times 16 seats, that's 480 seats in the general seating. So we know that maybe it is possible that no one will buy a seat in the general seating, but it's also possible they'll sell out. So that would be 480 seats, because 30 times 16 is 480. So our revenue equation is 10x, which represents $10 per seat in the general seating area, which could vary from 0 to 480, plus $3,000, which is the amount of the reserve seating which is already sold out. And again, we just list our constraint, the 0 to 480, by showing the inequality where X, it's the and situation that we dealt with in the previous chapter, where X is between 0 and 480, including 0 and 480. So if we ask the question, what is the maximum revenue? In that case, we would be choosing the maximum amount of ticket sales. So that would be $10 times 480 seats plus the $3,000. That gives us $7,800 for total revenue on the one concert. So before we look at the example is about the area of a rectangle. In the area of a rectangle, the formula is length times width. Generally, you make the width be the smaller side and the length be the longer side, but actually it doesn't matter that much as long as you have one of each. And actually there's 2 of each in a rectangle. Example 3, writing a nonlinear function rule. Geometry. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? So if we let W equal the width and A equal the area, and we note that width W is just W, but the length is actually the width plus 5, because the length was given as 5 feet more than its width, then the equation would be area equals length, which is the width plus 5, the length times the width plus 5 times the width itself. So what I would have, and the reason this is not linear, is if I distribute the w to both terms inside the parentheses, I get the area equals w times w, which is w squared, plus 5w. So I get an equation where the variable is squared. You'll note that when we've dealt with linear variables, the variable is not squared. When we square, we get a very different type of function. To answer the last question, what is the area of the rectangle when its width is 9 feet? So what is A when the width equals 9? So what I'm going to do is everywhere there's a W, I'm going to make that an empty parentheses. And so this will be like evaluating an expression in a sense. Inside of each one of those parentheses, I'm going to put the value of 9 for W. So what I end up with is 9 squared, which is 81, plus 9 times 5, which is 45, which is 126. But area is always in square feet or square units, so my final answer will also be in square units. So I have 126 square feet of area in this particular rectangle.